Good morning, everybody. Okay, just share my screen. Okay, last week there was one question regarding using Docker Compose, how we use front end and database and other middle layer application. So just want to explain that before we start about the Kubernetes. So this is how we write the Docker Compose file. The same WordPress for the demo purpose. And here I'm adding Nginx. I'm creating another Nginx instance. It will go to the back end and access the WordPress. And for that, we have to build the Docker Nginx file with the configuration. As we cannot enter the Docker container and do the Nginx updates. So for that we need to create a configuration file, and we need to build it. Show you. Here is Unix file. Using this Docker file, we will and here is a Docker file. Using this, we will build Nginx, and which will route like using a proxy pass to the web. So it will, what it do is it takes this Nginx file and copies to the Docker container to default Nginx location, writes the default Nginx file, and then it's builds up an image, and using that image it will start the Nginx. So when you see, we are not exposing WordPress port outside public, and we are only exposing Nginx file. So default Nginx will route it through proxy pass to the WordPress file. So this is how we can deploy like multi-layer multiple apps. If it middle layer can be anything, it can be any API or whatever you want, you can install, and front end we can do like the same. We can deploy on a node application or anything, we can do that. Okay. So that was the answer for the last question, which Mr. Yashwant has asked. And coming to about today's session. Today we'll be talking about Kubernetes and about the Kubernetes architecture and Kubernetes API server, and I'll like show you like how to install MiniCube, like for the development purpose, for the practice purpose, and a few samples like how we can deploy in MiniCube sample applications and all. So coming to Kubernetes. Kubernetes, it's nothing but it's just an open source platform for hosting all the image Docker applications or all image applications in a cluster environment. Kubernetes like it provides many options. One is like it is self-healing. It's automatic. It will roll back if at all, if it's any deployment fails, and it is like auto scaling. And it provides high availability. If at all any pod gets destroyed, it will automatically spin up many pods, and we have many options for like auto scaling based on memory, based on CPU. So and all the internal load balancing, everything it maintains. So what else it does for us? It's like it provides only a runtime Docker environment. It scales all the containers. All the stateless, mostly preferable is the stateless application containers we use, so that they don't have any dependency to create replicas, or when we create more multiple instances, and it maintains all the it will maintain health check. And if at all any pod or any container goes down or it crashes, automatically it will spin up a new pod and adds it to the load balancer. So there won't be any downtime. So the client will not face any downtime. And there will be rolling updates, and so that there were less, and we have like as we talked in Docker, we have like storage mounting options where we can you
Ram
maintain
Babu,
the
sorry.
persistent layer and save all the data.
I think it's a little bit breaking. I'm not sure if it's just for me. I just want to make sure.
No, it is breaking in between, Chad. Yeah.
Yes, it's breaking.
Yeah, it's slightly breaking in between, Ram Babu.
Yes, it's breaking.
Okay, just give me a minute. Change to is it fine now?
Yeah, please continue. We'll have to check because it's happening a little bit in between, not really very the same. But yeah, please continue.
Yeah. So it yeah, updating continuously. Okay. So whenever we do like deployments, automatic deployments, it will do like rolling updates, and if at all any issue, it will automatically roll back, and it has storage mounting options where we can deploy like for the persistent data storage applications. We can use storage mounting options, and it has like internal service discovery. If at all like all the load balancing from the ingress to the applications, everything is through the service discovery, and it maintains all the through all everything through the service discovery itself. So there is no like option maintaining through IP. If at all new container gets created, and we don't need to manually map everything. So it's based on everything based on the service name. And we have like options like labeling for the maintenance purpose, like labeling the nodes and everything. And if if at all we want to have like it gives an option to like selecting whichever node you want to deploy. So normally, like if we have example, we have 3 nodes or 4 nodes. You want to deploy, you want this application to go on particular 4th node. So we can there's like a variety of options where we can select label and push it to the only the particular node. These are all options provided by the Kubernetes to us. Okay, coming to Kubernetes architecture. I'll just brief you about the architecture. Like Kubernetes has like one is the master node, and others are the slave nodes, or you can say worker nodes, because most of the work, all the containers, everything are run on this nodes. They are called like worker nodes. Okay, first we'll discuss about the master node. Master node, like it requires 4 process, minimal 4 process it requires. It requires minimum 4 process. One is like API server. There is the controller and the scheduler, and the other one is the HCD processor. Okay. So what does this API server do? Like whenever all the developers or the users, whoever want to deploy or view the query, the Kubernetes, everything is done is like gone through the API server. It is like it is also like a cluster gateway, one time entry point. Either you use command line tools like kubectl, or if at all you use any dashboards, everything is like one time entry point is through the only API server. So it almost like it also acts like a gatekeeper, like all the authentication, everything is it's maintained, everything in the API server. Like if at all any request you want to deploy anything, first if you request it to the API server, then API server will validate whether you are having a valid credentials or a valid authorized user, and then it will send it to the next process, whether it is like scheduler or anything. Okay. And the next is the scheduler. Scheduler is like the name itself says like it will schedule everything. Like the pod has to go in like in which node, and it has to deploy in where it has to deploy, and And when you do like a replication, it maintains all the information of the nodes, and it decides, like suppose if you're deploying one application with two replicas. So what does how the request goes is, when it will go through the API server, API server will do all the validation, and then it sends the scheduler like this is a requirement, please deploy it. So what the scheduler will do is, example, we have our requirement is like 1 CPU and 2 GB RAM, and we have two nodes, for example. So what it does is, it will just verify the information of the two nodes, whichever is having, suppose one node was having around 30% of utilization and other one is having 40% of utilization. So what it does is, it will push, it will deploy the nodes, deploy the pods onto the nodes, whichever is less utilized, so that there won't be any issue for the deployment. So it does, this is the process which scheduler does. Okay, and coming to next is the controller node. So controller itself is like, name itself, it says it controls everything. It's like monitor or whatever you say, like a monitor things. It will verify each and every pod, node, everything, and it maintains, like if it will detect, like if the pod is running properly or is in a crash mode, or it's like in a pending state, or it's any failure. And it will detect everything. It will monitor. If at all any pod crashes or goes down, so what it does is, it will verify the state change, and then it will send the request to the scheduler like, okay, this is a requirement, deployment of this pod, and it requires this much minimum, and this is in a failed state, so we need to schedule a new pod. So again, the same procedure repeats. So the controller will verify this thing, and it will send it to the scheduler, and scheduler will again verify, like wherever available process or less utilized nodes are there, and it will deploy into that. So everything is, all the cluster health and everything, it monitors everything. This is the controller. And coming to the HCD, HCD is nothing but it's like a key value store. It is, you can also say, like it is a cluster brain of the Kubernetes. So it maintains all the information. We are having, suppose we are having 3 nodes. So it will maintain like 3 nodes information. It maintains everything in the HCD, and it is one node is having 60% utilization. Those information, everything is maintained in the HCD. And whenever a new deployment or anything, any change, everything, any happens, all the records are maintained in the HCD database. So that is why it's called like a cluster brain. So all the information, even the controller will get all the information from the HCD and validates with the nodes and pods, everything. That is what the HCD does everything. And coming to the worker node. The worker node, worker node requires like 3 main services, three processors. One is the container runtime. Like we are using Docker now. Most of the latest thing is the Docker. We are using like a CRI, and there is a kubelet. Another one is called kubeproxy. Okay, so Docker container, this CRI is like it all runs the Docker instances, everything in the worker node. And the kubelet, it is like interaction between worker node and the master node. So whenever any change or we do any query, or we deploy, or we do any installation, deployment, or any replication, increase everything. So what does API server does is, it will send this information to the kubelet. And kubelet, it will do all the process in the worker nodes. So every worker node will have its own kubelet, and it maintains all the worker node information, everything within the kubelet. So it is responsibility of the kubelet, to maintain all the pods, to deploy everything, and synchronize with the API server. That is the process of the kubelet. And the other one is kubeproxy. Kubeproxy is not just, you can see the proxy, the name itself defines. It's what does is it maintains all the it do all the routing and all everything. I mean, whenever a request is come to the like ingress or anything, so it will route to the particular pod. Example, I have like pod 1 here and pod 2. So whenever the information is come to ingress through service names, so the queue proxy will forward that request to the particular pod wherever it is deployed. It can be another in worker node 1 or worker node 2 or wherever it is. So that is the process of the queue proxy. Okay. So like a master is like normally it's the best practice is to have like multiple masters, because if at all we lose any information or any HCD information is down, then whole server is crashed. So for that purpose, what they do is they'll have multiple masters in a production environments, and they have and we can add any number of worker nodes to it. We can have 40 or 50 any nodes we can attach to it. So and so you just like same overview, like masters are responsible for it's like running the API servers, and maintain all the controllers, everything. And here we also have like a cloud controller. I'll explain it to you. Cloud controllers is like if at all you want to deploy anything in the clouds, it's like integration. Suppose I want to deploy my personal Kubernetes in a AWS managed instances, not going with the EKS. Like EKS is a service which AWS provides. If at all I want to manage my own, then what we do is we deploy like cloud controller, and we use a cloud provider specific driver, which will help to like use the services of the cloud. Like we can attach storage from the clouds, or we can spin up any load balancers. For this purpose, we use these cloud controllers and the cloud provider drivers. Okay. The same I'm explaining it like API server, etcd, etcd, kube controller, cloud control manager, and the kube scheduler. These are all the 4 services makes the master node. And the same kube API server, it's like as I explained, it's like REST interface to control all the master and the data store, all the clients and nodes, everything. It will interact with only the API server. It's only a single point of interaction, like a gateway. Okay. HCD, it's like as I told you, it's a cluster data store, everything as I explained, the same in same architecture. And here, this is what the controller cloud control manager daemon. It's like provides that cloud specific driver and integration to it. So whenever mostly we require this because of maintaining all the storage and all. So that for that purpose, it will be mainly utilized using the cloud controller and cloud provider driver. And the node components. It's a kubelet node components, as I explained. The kube proxy does all the forwarding and all, and Docker is we are using the containers. Okay, and okay, and I'll explain you about the like the MiniCube installation, where we can do some practices and all. Most probably in the next session we'll start do installing in a Linux cluster and all. For today we'll do a MiniCube installation, and where we can install it in your own local laptop. It's like for the developing purpose and all, for testing we can use this. And I already set up, because it's around, it will take almost around 1 GB. So I have already downloaded it and set it up in my local. So I'll just start it. So when you install MiniCube, you'll also get like kubectl commands and everything. And kubectl we use, it's like a command line tool which will interact with the API server and does all the work for us. We can deploy pods, so we can scale the pods. We can replicate the pods. Now, if I say, okay, so whenever this is what I think some issue is there, creating configurator. So whenever you spin up a master server, there is a different command when we install in the cluster. Here is a MiniCube. So you can see all these commands: etcd, API server, controller manager, kube scheduler. So these are the main and the kube proxy. Kube proxy and everything is like we have a issue here. So as I explained, like kube server, whenever we run anything, now I executed this kubectl get pods command. So it will query the API server and gives the information and displays the information to us. Okay. So normally, like everything kube config will be available when we install kubectl client separately, and when we configure our remote for the remote Kubernetes cluster, we store all that information in this .kube file in the home directory. Okay. So right now, I'm doing a deployment, just a sample deployment. It will. Okay. So whenever we do any deployment, it will create a deployment config, and it will create a deployment config. I'll explain you. So here is I'm just describing the configuration, like what it is saying. So here is a namespace, and in Kubernetes we have a concept called namespace. We can it's like segregate pods into different namespaces. Example, like you want to maintain dev, QA, like it's like a tagging. So we can create a namespace like with a dev, and we can deploy all the applications related to dev in the dev namespace. And for QA, we can create a namespace like QA, and we can deploy it every there. It's like a tagging, namespace tagging. And here you can see the labels we can add. This application is labeled like hello MiniCube. This is what the options were, which I told, like what it does, all the labels and all. And here I'm telling that we are using only one replica. So if at all we deploy in a high availability mode, like auto scaling and all, there we mention like how many replicas, like minimum replicas, how many we needed, and maximum replicas, how many maximum replicas we can mention here. I mean, it's only a command through command line deployment. Later in the next sessions, I'll tell you like how we can create the YAML file for the deployment, or how we can construct the YAML file, and what will be the services and everything. I'll explain in the coming sessions. So the strategy is like always it will be the like rolling updates, and the strategy is like 25 max unavailable, 25 max search. If at all we give like replicas, it will deploy update like that in that perspective. And this is the image which we have used here. We am specify hyphen image. So this is the image which I pull it from the GCR repository. And it will give the events. All the events are mentioned here. So it's deployment control message scaled up to replica set to 1. So since we are using only one replica set, it is only it's spinned off only one instance. No. So I'm just using only namespace like default. So you can see like we can see only one pod running, that is the hello MiniCube which we have defined. Now here this is what I have said, like namespace. I'm using like only default namespace which I showed. If at all I want to view all the pods running in all the namespaces. Yeah. So all the master and everything, it runs on Cube system namespace, and there is one default namespace where we can deploy. If at all I want to create a new namespace. Now you can see like what all namespaces I have. I have default namespace, the dev which just created 6 seconds ago, and the cube node list, cube node cube public, and the cube system. So these are all the active namespaces, and this is how the pods are segregated. Okay, so I just showed you deployments and the pods. Okay, now we can expose the service name and browse the application. There are different types, like here I'm showing like a node port. When we deploy in a cluster and multiple worker nodes, then probably we'll be using a cluster IP instead of a node port. Node port is like accessing directly, exposing directly the node port of the pod container. So if in cluster and multi-stage applications and high availability applications, when we spin up 2 or 3 or multiple pods, then probably what we do is we use cluster IP mode, and all the backend is done with the service name. So whenever we deploy anything, I told you, right? So everything is exposed through service name. So this is the IP which has been assigned to hello MiniCube, but all the routing, everything is done with the service name itself. For example, I'm deleting this pod. Okay. So we started this pod, earlier pod, 5 minutes ago. So when we just deleted that pod, what happened is it created again a new pod. So the controller node sees that pod got deleted, and in the deployment we have active in the deployment config we already have like the requirement is 1 pod. So what it does is again it will send information to scheduler, and the scheduler spins up the pod again. Okay, so since we are using like MiniCube and we don't have any active ingress controllers, so what we have to do is we are just doing a port forward. If at all we do any ingress controllers thing, then automatically it adds the service to that, and it gives a public IP, and through that IP we can access those services. So for demo and for our development, we use like port forward service in the MiniCube. So now what I have done is I have exposed the port of the application. I'll just access. So here is that we are able to access that application through 7080 port as we expose it publicly. And yeah, so just canceling the port forward. So once you just Control C, the port forward service will be stopped, and we can. So this is the get events when we can find out all the events, whatever Kubernetes has been doing. All the events are stored. So this is the command to get all the events, what happened, whatever it is performing. It's like a log of the kube server. You know, like what has been done from the. So these are all the events happening. So node is ready. It is starting kubelet, all thing. It's allocated limit across pods. So all the events and all we can find here. And one more is get nodes. This is a get nodes is the command. So if at all when if we have like multiple pods or multiple nodes, everything using this we can know. Example I will show you. This is another server. So here it is. I have like one master and 7 nodes. So when you type nodes, it will give all the information like what is the name and all. Here we can set what are the roles. Only one master is there and others are only worker nodes. And here you can see there is a command called node top. It will be only activated once there is a plugin called metrics. We need to deploy that. Once we deploy that, it will give all the information like which node is running, how much CPU it is utilized, how much memory it is utilized, everything, all the information it will display. Example like 192. This is my master node. So my master node has very less utilization because here we are not running any pods. Only Kube API servers. All these only 4 services will be running. So there will be very less load, and all the these are all the worker nodes. Oh, here like ATM. So like and 2.7 GB memory has been utilized. This is the option. Yeah. kubectl config view. When if you want to view the like configuration, what at all it is. So if kubectl config view will display everything. Like this is my MiniCube configuration. What is a client certificate, what it is, what is a version, what is a provider. I'll show you this. So it will be having here. So this is the clusters and this is the server IP address, and what is the cluster name, and what is the user, and everything it provides. And here I'm showing is like it is Kubernetes private kube cluster and on AWS. Here you can see I was telling in the earlier like cloud providers. Here we are using like cloud provider like AWS. So what happens is with this cloud provider drivers, I will be able to use all the services which AWS provides. Like, and I can map the storage, EBS volumes, or I can map the EFS volumes, or I can spin off a load balancer and attach to this Kubernetes cluster. So that is the purpose of this cloud provider drivers which we use. Now if we normally go to a like bare metal server, like installing it in a Linux server, it's called a bare metal, and there you will not be able to use this cloud provider because all the storage and all it will be maintained locally. And okay, and these are the commands for like remove the service, delete. If at all you want to practice and to make it better understand how to delete, create the service and delete everything. So just just I want to delete this service. So what I need to do is kubectl delete service and service name. We need to. This is just anything. The command structure is kubectl, and whatever the service action you want to create or delete anything, and what type of you want service or deployment, anything, and the next is the service name. If you want to delete deployment, kubectl delete deployment name. This is the structure. So the service is deleted, and the next is I want to delete the deployment. So kubectl get deployments. So this is the only active deployments I have. So if at all I want to delete this, if I have multiple, then the command is same, kubectl delete deployment, the deployment name. So get deployments. So there are no resources now. So this is this is about the Kubernetes architecture and how they perform, and how they route the requests, and how it is managed internally. And you can spin up this for testing. You can spin up the services, you can scale them, and you can deploy them, you can expose the service, and you can delete. That is about the today's session. So if at all you have any doubts, please do let me know. I'll be able to address it. Hello.
Hello. Yes. If anyone have any questions, please unmute yourself and feel free to ask Rambabu, or you can even post it on the chat.
Appreciate it. Rambabu, thanks for another beautiful session. And I see some like Yam Khan, Manav, maybe Naga. So you don't have Testoper Teams email IDs, even Howard. If you guys want it, you can actually see the chat and copy the procedures and request us an ID, so you can collaborate in our platform and help others learn from you, and also you learn from others. We really appreciate you contributing on that. The other thing is, by any chance you're looking or not looking, send your resumes. From Testoper community, there's a lot of companies come to us and ask if you have some community members having this expertise, so we would be able to kind of refer you to those opportunities. So feel free to send your resumes. You can actually send your resumes to testoper@testoper.com. I'll just type it in here in the chat. All right. And finally, if you are interested to also provide some sessions to help others to learn, as you all know, Testoper is a non-profit community. So it's run by volunteers, trained by volunteers, other volunteers, and so on. So if you are interested to contribute and also join other programs which are in the Eventbrite, feel free to do so. So one of the activity that we are starting is we are creating something called as a decoding 5G. For Skill Up and Innovation Up for the members who wants to develop their career on the 5G technology and eventually 6G technology. We are starting that initiative, and there is if you go to the Eventbrite, the first meetup where we are going to launch that is happening on September 18th, Saturday morning, 10 a.m. We have great speakers from IBM, Facebook, as well as executive director of Canada Wireless Internet Service Provider Forum, Industry Forum. So please feel free to join that in the Eventbrite. I would really love to see you guys there, and also in other programs that we are doing. The last request I have is make sure that we have 3 more programs, 3 more sessions of this. Rambabu will be taking it. Make sure that you also attend that for subsequent 3 weeks. And learn from it, right? So those are my key inputs. Rambabu, ask to you is like you always do. Please send what you covered today, what you are planning to cover next week, so that I can send it out to the team. Okay?
Yeah, sure, Kadan. I'll send it.
This is awesome. So any questions or anything from the team?
Hi.
Yeah,
Thanks,
hi.
Rambabu, for today's session. I just wanted to ask, is the slide available on Teams now that we can go and practice?
Yeah.
Okay.
So I have provided we can install the MiniCube and we can practice. All the instructions are there in the presentation, which will be shared.
Okay. Thank you.
So normally, Greg, what happens is after the session, Rambabu sends the presentation to our volunteer, and they actually post it, and then they also, instruct in the teams that the location of the presentation and also the videos in the YouTube, right?
Okay.
You can follow in the Codathon channel in Teams, so you will know.
Thanks.
Yeah.
Rambabu, still, like, what kind of infrastructure or cloud credentials do we need to implement Kubernetes?
See, there are multiple services. If at all you want to go with different clouds, they provide their managed services. It is AWS gives like EKS, and Google provides its own cloud. Azure provides its own Kubernetes, and we have private Kubernetes where we can use cloud provider driver, which I showed you. Using cloud provider drivers, we can spin up maintain our own Kubernetes instead of going the managed services. So if at all you want to install in a own physical servers, that I'll be covering in the next sessions. I'll explain like how we can install in our own Linux machines, and how we can create a cluster out, join the cluster, and do the deployments. I will show you in the next coming sessions.
Thank you.
Yeah. Okay.
Awesome. All right. So if there is no questions, then probably we can take 12 minutes of our Saturday time and go back and have some good time with family. The weather is also good. Thank you guys for joining. Thank you, Ram and Kavita, for your continuous contribution towards the Testoper community. You make a lot of difference. During the summer, what happens is people attend a little bit less, but you can actually go and see a lot of people view the videos after that, right? That's also a drawback, because sometimes videos is there, people tend to not join the live sessions. But the live session is always the live session, right? You get the feel of learning. And I wanted to thank every one of you joining today. I'm looking forward that each of you will join the next week's Saturday program. Have a wonderful weekend. Talk to you all soon, guys. Take care. Bye-bye.
Bye.
Thank you. Thank you, Rambabu. Thank you, everyone. Bye-bye.
Thank you.